Welcome to this session on equivalence partitioning and boundary value analysis, two of the most widely used test design techniques. Mastering these methods will help you create efficient, targeted tests that uncover defects quickly while minimizing redundancy. Let's begin with equivalence partitioning. This technique divides input data into partitions or classes where each member is expected to behave the same way. The idea is simple. If one value in a partition passes, the others are likely to as well. Similarly, if one fails, the rest probably will too. So instead of testing every possible input, you test just one value from each partition. Equivalence partitions are typically divided into valid and invalid classes. For example, if an input field accepts ages from 18 to 60, you create one valid partition, 18 to 60, and two invalid partitions, below 18 and above 60. You might test age 25 for the valid class, 16 for the below range, and 65 for the above range. This technique is powerful because it reduces the number of test cases without sacrificing coverage. It works well for inputs like ranges, formats, and categories. Next is boundary value analysis, often used alongside equivalence partitioning. This technique targets the edges of partitions, which are common sources of defects. Developers often make mistakes when coding boundary conditions, like greater than instead of greater than or equal to. Using our earlier example of age 18 to 60, you would test the boundary values 17, 18, 60, and 61. These are the minimum and maximum valid values and the values just outside the range. Testing these edges helps ensure the application handles limits correctly. Boundary value analysis is especially effective for numeric fields, date ranges, and any condition involving minimum and maximum values. It's based on the observation that errors often occur at the edges of input domains, not in the middle. Here's how you can combine both techniques in your test planning. First, use equivalence partitioning to identify input classes. Then, apply boundary value analysis to test values at the edges of those classes. This ensures both representative and edge case validation. Let's walk through a quick example. Say you're testing a form that accepts a PIN number from 1000 to 99999. Your equivalence partitions would include valid 1000 to 9999, invalid low, less than 1000, invalid high, greater than 9999. Then you apply boundary testing. Minus 999, 1000, 9999, 1000. Just these few cases offer robust coverage without overwhelming the test suite. These techniques are efficient and systematic, making them ideal for early-stage test design, especially when detailed documentation is limited. They can be used in manual and automated testing alike, and they align well with agile practices where speed and precision are critical. To summarize, equivalence partitioning groups inputs into similar categories to reduce test volume. Boundary value analysis focuses on edge conditions where errors are most likely. Together, they help create lean, powerful test cases that improve quality and reduce risk. In our next session, we'll explore decision tables and state transition testing, more structured techniques for modeling complex logic. Keep going. Your testing toolkit is getting stronger.